Section 1.2 is all about the graphs of functions and what we can learn from them. So a really important concept is what are the zeros of a function? So if f of r being some x value, equals 0 for any real number r, then r is called a real root of 0. Remember, now we're focusing on the real number line. We'll talk about complex numbers later on in this course. That would mean that r is an x-intercept. That's where our function crosses the x-axis. So that x-intercept point is on our graph. If we have a quadratic function, for example, that'd be something of the form f of x equals ax squared plus bx plus c. We're building up to these. They can either have no zeros if their vertex is above the x-axis. They can have 1 0 if their vertex is on the axis, or they can have 2 zeros if their vertex starts below the axis. This is their vertex. We're going to talk more about how zeros relate to the degree of a function as we move along in this course. So what are some things that I can learn from a function or a graph? Well, I could learn what the x and y intercepts are. To find the x-intercepts, I let y equals 0, and to find the y-intercepts, I let x equal 0. It's the opposites. It's also important to know, does this function have symmetry? That's something we're going to talk about in the next couple sections. I also want to know a function's domain and range if possible. It's also really important to be able to find a specific y value, or f of x, given an x. That tells us a point on the line, or a specific values over an interval can be important as well. So let's first look at a function, and then we'll look at a graph, and we'll see what we can glean from those. So let's change colors. If I have f of x equals x squared plus 2 over x plus 4, this is a rational function. Remember, that means its domain is all values of x where it won't equal 0, but I've got x plus 4. So if x was negative 4, then my denominator would equal 0, which would be bad news bears. So the domain of this function is x such that x doesn't equal negative 4. And I may have already answered one of our questions. See, I did. Oops. That's okay. So the first thing I want to know is the point when x is 1, y is 3/5 on the graph of f. So what we're always going to want to do is substitute in our x value and solve for y. So if I have f of 1 equals 1 squared plus 2 over 1 plus 4, that gives me 3/5, which is our y value. So yes, this point is on our graph. What if I want to know what f of x is when x equals 0? We do the same thing. F of 0 equals 0 squared plus 2 over 0 plus 4, which equals 2/4 or 1/2. Always remember to simplify all fractions. Okay, I already know the domain. It's a rational function, so its domain excludes all values that would make its denominator 0. And let's list the x-intercepts if there are any. Remember, your function doesn't have to have any. So I'm going to go ahead, and in order to find the x-intercepts, you let y, which is f of x, equal 0. So I have 0 equals x squared plus 2 over x plus 4. I multiply both sides by x plus 4. This will cancel out my denominator. 0 times anything is just 0. So I have 0 equals x squared plus 2. Subtract 2. I get negative 2 equals x squared. Then I can take the square root. But wait, now I'm taking a square root of a negative number. We're working in the real world. These would be complex intercepts, and that's what we don't want. So there are no x-intercepts. Next, I want us to list the y-intercepts, if there are any. Well, in order to find the y-intercepts, you let x equal 0. But wait, we already did that. So I now know that when x is 0, y is 1/2. That's our y-intercept, and there's only one of those. Remember, if it had 2, it wouldn't be a function. So, probative for thought. You can also be given a picture of a graph. Look at this beautiful graph. We've been on the internet, now we're great friends. Okay, so let's use this graph to answer the following. What is f of 5? That's saying, what is the y value when x is 5? Well, when x is 5, y is 4. So what is f of negative 5? Well, when x is negative 5, y is 1. What are the X and Y intercepts? So the X-intercepts are going to be wherever our graph crosses the X-axis. It's going to be these 2 points. I'm actually going to switch colors and label them in green. So that's when X is -1, 0, or 3, 0. And my Y-intercept is going to be this point right here where it crosses the Y-axis. That's when X is 0 and Y is -2. What's the domain? Well, our domain, I don't want that color. Let's go back to blue. Our domain is all possible values of X, which goes from -5 to 7. And our endpoints are included, so we're going to use brackets instead of parentheses. And our range goes from -2 to 4. And again, I'm using brackets. It may not look like a bracket, but I swear that's a bracket. Next, I want to know how often does the line y = 2 intersect our graph. Let's look at where y = 2. Okay, this is the line y = 2. Its graph is a horizontal line. It crosses the graph 1, 2, 3, 4 times. How often does the line x = 5 intersect the graph? Well, remember this is a function, so it should just be 1. And for what value of x does f of x = 3? This is a trick question. I'm so sneaky. So let's look at when y = 3. Well, y = 3 here, but it also equals 3 here and here. There's more than one value. So it's y, the x values would be -3, and then we can just kind of guess, like 4.5, 5.5. On a computer or on your calculator, you could make that more accurate, but right now we're just guessing. So there's actually 3 values. That was the last example for section 1.2. If you have any questions, feel free to put them in the comments or send me an email.